right, so for each light bulb, what happens to the brightness when the current decreases? Let me just turn this over. Well, if you think about current, the current is the amount of charge that is flowing through a wire. And that amount of charge is representative of electricity. Electricity is the movement of charges. Well, the more charge you have flowing, then the higher your current, and the higher your current, the more electricity. As a result, you get a brighter bulb, but if you reduce the current, you get a dimmer light bulb. The other thing I wanted to highlight is that brightness is directly related to power. Is directly related to power, which we established last class is equal to current times voltage. So if the current goes up, the power goes up, and if the power goes up, the brightness goes up. In the same sense, if I added an extra battery, if I added more voltage to it, you would have a brighter bulb. I think some of you were able to play around with multiple batteries when we did our little project or like played around with the light bulbs last class. And you saw that adding more batteries gives it more voltage, directly affects power, and therefore you get a brighter bulb. So power and brightness are directly related. And obviously that involves current. For questions? For number 2, I realized these images were not mixed up very well. And the first set were all parallel. The thing you want to think about parallel is how each resistor is connected to the battery. They all have their own individual loop to the battery. And that goes for every single one. So A, B, and C are parallel. And the benefits to parallel is if I accidentally broke one light bulb, the other light bulb would work. Now, in D, series means there's only one loop and that all your light bulbs and all your resistors are in the same loop. And the problem with series is that if you break one light bulb, that cuts off the current, it creates an open circuit, and then everything else is going to stop working as well. So the series circuits would be D, E, and F, all series. There are some benefits to series, and that's the fact that you only need one wire for series versus a gazillion wires for parallel. And in fact, your electric house project is going to involve quite a few wires because you're going to do one series and one parallel. And so getting all those wires organized can get tricky. And I want to make sure that you label your wires carefully so I know which ones need to connect to the battery. Questions on 2, being able to identify series and parallel. The next one is part 3 where it says, what does it say? Is there anything wrong with the drawings there and why? So the light bulb orientation is definitely wrong. Have you ever seen wires connected to the top of the bulb and out the bottom? Connected to the glass? Why wouldn't that work? Why can't you connect it to the... Perfect. You need it to attach to a conductor, and glass is not a conductor. What you do have to do, though, is you have to connect it to the bottom where there's conductive metal, but it has to come in through the bottom conductor and out through the side conductor. So it should look like this, and then come back up around the top. The series might be easier to see in through the bottom, out through the side, and never touching non-conducting material of your wire. I probably set it up wrong. It should be like this, right? Back to the battery. Yeah. So in.
That makes sense. Sorry.
No, that was just me not thinking. Good. Any other questions? Thank you for pointing that out. Okay. The last one is kind of what I went over here. How would you make a light bulb light? How would you have to orient it? So first you need a complete circuit. A wire at the one end of the battery connected to the side of the light. I like to use an image. Makes it easier to visualize and understand. So you need it connected to one side of the battery. This is like the little coils. And out the side of the light bulb and in the other side of the light bulb. So we've got our positive, negative, and then we've got our end and the side of our conductive screw. So for light bulbs, it has to be specifically connected in that way. The battery part, you guys basically have that understanding because you put batteries into devices all the time. Any questions on this warm-up?